So in this video, I'll walk you through how to use the IDEA functions within your custom functions, and then I'll give you an example of creating a custom function using the Visual Basic, which is the same as the programming language that's used for IDEA scripts. So again, what we'll do is we'll use an example here. Assume that for the customer number that the first two digits here is the Geo Region, the geographical region. And we want to create a custom function that will automatically extract the first two digits. Yes, we can do it quite easily just using the @left function within the equation editor, but for this example, we'll create a special custom function just to do this. So again, I'll go into field manipulation. I'm going to create a new field. I'm going to call this Geo Region. This is be a character because this field is a character and I want the first two characters, so our type will be character. I'm going to say length 2. I'm going parameter. Against, I want to create a new custom function. I click on the number button or the custom functions button, and then I click on new. This one I'm going to call Geo Region. And we're going to have one parameter, which is the field that contains the information that has the Geo Region in it as the first two characters. And I'm just going to call this the region field. I'll say field that contains first two characters of the Geo Region. Yep, and it was sorry if you may notice I said okay, and it gives me a parameter name is invalid because it doesn't like spaces, so I have to put in an underscore. Then help text I'm just going to leave blank for right now. But here for the function, like I said before, this is easily done by using the left function, and this is how we're going to do it now with the custom function. With the custom functions, you can access all the IDEA equation editor functions in there. So what I'm going to do is I'm just going to say geo, and actually I want to have an underscore there so it doesn't give me problems, is equal to, and how to access the functions within the equation editor is you place an I in front of it. So it's IDEA, I, just think of IDEA, so it'll be left, and then it'd be the region underscore field, comma 2 for the two characters. And here I can test it out. And since it's a character field I'm looking at, I have to put it within double quotes. So say it's got 1, 0, 1, 2, 3. So hopefully this will give me back 1, 0. It does give me back 1, 0, so it's giving me back the expected result. So I click on validate, no errors. I click on save. I get out of there. It's been added. Now I get out of the custom functions. If we go down here, we can see that that's been added too. So now if I just want to do that, Geo Region, and that was which field here? It was the customer number. Then I click on validate, click on OK. And if we go over, and there it is. So like I said, you can easily do it, but sometimes you may have long equations that use up lots of the functions or the IDEA functions. So instead of, this is another alternative to saving the functions, you may want to create it a bit more generic and use the custom functions, and that way it'll be available in all your other IDEA analysis. You know, so it could be something that is worthwhile, especially if it's something that you use over and over again. Now I want to just do the last thing, which is create something a bit more interesting using Visual Basic. This is actually something that's on my site, the IDEAScripting site. What I'm going to redo is something called the LUN formula, or the LUN algorithm. What this does is it validates things like Visa cards, MasterCards, all kind of credit cards. It also works for SIN numbers, IMEI numbers, national provider identifier numbers in the US. They all use the LUN algorithm to validate it. And here, for the description, This is actually Wikipedia for the Lund algorithm. They give you the example of how it works. Basically, what it does is you take the number, you'll double each second number. If it's over 10, you add them together, then you add them all up, then you divide them by 10, and if the remainder is 0, then it is been validated. If it's not, then it hasn't been validated and it's an incorrect number. So that's used, like, it's a very common checksum used, like I said, for all kind of credit cards, MasterCards, and everything like that. Fortunately, what I did is I searched around, and instead of me recreating this, even though I have the logic, sometimes you want to take the easy way out, so using Google, I found a site where some other programmer has actually created it in Visual Basic. And Visual Basic is what is used for the IDEA script. It's not exactly the same. You have to do certain types of modifications, but it's usually close enough that anything you have to change can be changed quite easily. I can point out some of the differences here, such as for the lun.substring, this would give you access to the different characters. Within IDEAScript, what we'd have to do is use the mid. So instead of lun.subscreen, we said this digit equals mid, open parentheses, lun, which holds the number, comma, the position, comma, the number of digits. So that's one difference right here. Another difference is within a lot of languages, if you're adding something to itself, you don't have to repeat the variable. So here we're saying this digit is multiplied by 2. So this digit is equal to this digit star 2, or multiplied by 2. Like I said, within IDEAScripting, you have to write it out the long way. The star equals does not work. And same thing here, running total plus equals, that doesn't work either. You have to write it out long using all the other variables. But other than that, the syntax is very much the same. That will keep. So now if I go back to IDEA, I'm going to create, what I've already done is I've created a database with 1,000 credit card numbers. Where I got them from is we go back. There's a site called Credit Card Numbers Generator, and it allows you to generate numbers for different kinds of visas, MasterCards, Discover, En route, and I use this to basically generate 100 numbers for each one of these cards that I can use to validate that I don't have any syntax errors and that I have the proper formula in the custom function. So I'm going to, again, go into field manipulation. I'm going to create a field called valid. This function here will return a numeric amount. So I'm going to leave it as numeric. I'm going to go into parameters. Again, we're going to go in and go custom functions. I'm going to do a new, and we're just going to call this the lun, whoops, I always do that, formula. And I'll just make this a bit larger so we can see more of it. And the output type will be numeric. And what we want to do is say that if the number is valid, returns 1, if not, returns 0. So if it's a valid number, it returns a 1, which in most programming languages means it's true. If not, it returns a 0. So we only want one parameter, which will be the character, which will be the actual lun number. So I'm just going to call this the lun. So this is being the character field to validate. And now I'll start writing the actual code within there. So we've already got it set up. It's already showing the lun formula. So this will be returning a double. So we're returning a number, and our input is a string. It's a character string. So first thing I may want to do is I may want to make sure that there's no characters, because I'm looking at a number. So I only want to look at items that I don't want to bother validating any information that isn't actually a number in there. So I can do something like if not is numeric. So this is a Visual Basic command that checks to see if a variable is numeric or not. Then, and as I said before, to send the information back to IDEA, I make it equal to the function name, and I'll say equal to 0, so it's false. Also, I want to make sure that it's not negative, so I can put in an else if, and then say ln less than -1. Then again, equal to 0. And then finally, I can actually write the code that goes into validated. So now I know that it's the numeric and it's not less than 0. So now the code, if you remember, if we go back here to the validation code, what the person did first is that he reversed the numbers. You have to reverse the numbers. Then he got the length. Then he'll go through and look at each digit one by one. So if the digit is an even digit, then he multiplies it by 2. If that digit is then, if the multiplication is then larger than 9, he would add the 2 values. So if it was, say the digit was 7. So then we multiply it by 2, it gives you 14, which is greater than 9. And what we'd end up doing is 14, we take the 1, add it to the 4, so then this digit's equal to 5. And then we'd take the running total and add that 5 to the running total. Otherwise, we're just taking the regular numbers to the running total. So I'll just go back, find the screen, and I'm just going to be lazy and copy in the code that I've already created. And I'm just going to make sure I haven't defined my variables yet, and I'll do that in a second. So, like I said, I've used a function, and this is a Visual Basic function, string to reverse. So what it does is it'll take a character and turn it right around. Then I find out the length. Then for each character, I look at each one. So I go grab each character one by one. If it's an even, so if it's divisible by 2, then I multiply it by 2. If it's greater than 9, then I'll take the 2 digits, add them together, and I add this to the total. So the I total is the actual total that I'm keeping. It's the cumulative total. And if not, well, then I just keep on adding these digits, just like it says in the instructions. And I'm just going to go back and I had define some variables at the very beginning. Because I have the option explicit, I have to always define the variables, which is a good habit to get into. So I defined one variable for the length of the field, another variable that will hold the character digit one by one that we'll look at. I is the integer that I use to go through the loop, the for loop, and the total is the numeric field that I keep the cumulative total of the MasterCard, or whatever card I may be card number I may be looking at. And also what I've done here is I've automatically assumed it's false, and I have to prove that it's true within the code. So there I validated it, and then at the very end, what I want to do is I want to see if the total is actually divisible by 10. So if it's divisible by 10, it returns a 1. If not, it's going to be returning a 0. 1 is true, so if it's divisible by 2, we know it works. If it's not, it's divisible by 0, it's false. And if I go back and grab a credit card number from the front of it, this is one of the MasterCard numbers, and I put it in. And since it's a character, I have to put it within double quotes. I do test, and it gives me a 1 because this is a valid credit card number. So then I click on validate. There's no errors. I click on save function. Then I click, I'll escape there. So we got the one formula. I'll escape out of it again. So now I'm going to do the test, London formula, and we want the credit card number field. I'm going to add that. I'll say OK, say yes. And there we go. And they all show up valid except for one error that I put where I brought in the heading twice. That was my fault. But all the other ones is ones, which hopefully makes sense because I got these from the site, and these are all supposedly valid credit card numbers. So maybe you want to test it out with your own credit card numbers. So anyways, this shows you how easy it is to use custom functions and how versatile. Because if you remember, if we go back and look for the LUN formula, especially, sorry, going to do edit. If we go back and look at it, you know, there's actually a for loop. This would be very, very difficult to perform within the equation editor. You know, it would be possible, but the equation would be quite long and probably not something you want to do. Versus doing it in IDEAScript using the custom functions, it makes it quite easy because you have the access to all the programming languages, variables, and looping structures. So hopefully this has given you a better idea of the different custom functions. This LUN formula is available on the site, along with many others. And there are other custom functions within IDEA that you can use. So I hope these two videos were helpful, gives you a better idea of how custom functions work. And if you have any questions, please feel free to post them in the forum. Thank you.